Ever wondered how those old school cassette decks and tape recorders create magic with just a strip of magnetic tape? Welcome back to Gary Keep It Simple, where today we're stepping into the enchanting world of analog audio. But don't fret, we're stripping away the jargon to keep it as simple as our name promises. Whether you're revisiting your cherished mixtapes or diving into cassettes for the first time, this video is your gateway to mastering the art of perfect recording. Let's unravel the mystery and together rediscover the warmth of analog sound. I've done my best to make this as simple as possible. I will cover the mechanism, the way the recordings work, and at the end we can see the results. So let's get started. Now let's take a look at a cassette deck. This is what you put the tape into. It's a standard two-head deck with a combined record and playback head and an erase head. I've labelled this up so you can see exactly what's what and how it works. In cassette decks, the supply reel and the take-up reel simply supply the tape and take it up. They don't control the movement of the tape except in fast forward and rewind. When the deck is playing, the take-up spool just takes the tape away from the mechanism. If it's pulling too hard, that's a fault that needs addressing. The capstan and the pinch roller control the speed and the wow and flutter. It's all down to the capstan and the pinch roller. Next, let's look at the erase head on the left-hand side. It is a very precise electromagnet that wipes along the tape and erases the magnetic recorded signal. In the middle, we have the record playback head. This takes the signal from what you're feeding in and puts it onto the tape. When you're in replay, it pulls it off so that you can hear, but it doesn't remove the signal from the tape. Finally, we're back to the capstan and pinch roller. The pinch roller pushes the tape against the capstan, which is controlled by a servo control motor. This means it's very stable at speed and constant. The pinch roller pushes the tape against it, and that's how the tape is pulled through. There is a video on my channel which explains this more thoroughly. It is very important to keep the capstan and pinch roller clean and grease free. Remember, we're dragging a piece of plastic tape with metal stuck to it. You never know where it's been, and so when they get dirty, there will be debris that come off. It is very important that you keep these two parts clean to avoid any problems with chewing tapes. Just to clarify, the tape comes off the supply reel, goes down across the erase head where it gets erased before it is recording on, or where it does nothing if the tape is being played back. Then it goes across the record playback head, then it goes through the capstan and pinch roller where it is being squeezed. Then it goes back up onto the take-up reel. That's the way it's done. It's nice and simple. All speed control is done by the capstan, and there should be no great problems on this sort of deck. Now we're going to look at the way the heads actually sit in a cassette. You can see here the tape comes down from the supply reel. The tape then moves around a roller, passing over the erase head. This head can be turned on and off electrically, and its position doesn't matter. If it's forward, it can be used as required. The tape then passes over the record playback head and goes through between the capstan and the pinch roller, around the roller at the end and out onto the take-up reel. It's a simple process, typical of a two-head single capstan machine, which is what most people have. Now let's look at a similar setup, but with two capstans and two pinch rollers, and one head in the middle. This is what you'd find on an auto-reverse playback deck, or a deck with a closed-loop dual capstan, or maybe a three-head deck with that function. It could be a two-head deck depending on the quality of the deck you have. This setup is the same as the previous one, but with two pinch rollers and capstans. The erase head is moved because its original location is where the pinch roller is, and because of the slightly different location in the cassette, the erase head is now quite small, but it does exactly the same job in exactly the same way. This brings us to a three-head deck. If you look, you can see the small erase head, and then on the right hand side you have the playback head and the record head. This deck, a high-end one, has the closed-loop dual capstan type mechanism that I mentioned before. This sort of deck is prized by collectors, and if you've got one, you're doing well for yourself. Now let's talk about bias, more properly known as recording bias. No, it doesn't mean what kind of music you like. Tape bias is a term for two techniques, AC bias and DC bias, that improve the fidelity of analog tape recorders. DC bias is the addition of direct current to the audio signal that is being recorded. AC bias is the addition of an inaudible high-frequency signal, generally around 40 to 150 kHz, to the audio signal. Most contemporary tape recorders use AC bias. When recording, magnetic tape has a nonlinear response, as determined by the coercivity. Without bias, the response results in poor performance especially at low signal levels. A recording signal that generates a magnetic field less than the tape's coercivity cannot magnetize a tape and produces little playback signal. Bias increases the signal quality of most recordings significantly by pushing the signal onto the more linear zones of the tape's magnetic transfer function. To put that into simple words, if you haven't got enough oomph, you're not going to get anything onto the tape, so they need to add some oomph in the form of bias. DC bias is like hitting it with a sledgehammer, whereas AC bias is like tickling it in a way that you want to be tickled. When you look at the signal, you'll notice it's not managing to get off the bottom line. We want it to be between the other two lines. If it's only the top of the signal that's being recorded, we raise it to be the part of the tape where the recordings will be full and good. We don't want it to be too high or too low. We want it to be nicely in the middle, where it is linear. We could just jack it up with DC bias, but the trouble with DC is that it's just one lump of something. It's hard to visualize, so let me give you a visual metaphor. Imagine a person running around pushing a vibrating machine. The sound gets compacted far better than bashing it with a shovel. You look at this and you think, oh, what's this then? This is how they deal with powders, trying to get them into small spaces, trying to get them to mould, trying to get them to do what they want them to do. You can think of the tape as being in the same situation. By hitting it with a vibrated signal, which is the AC bias, you can get the tape to do what you want it to do, nice, neat and small. In effect, it becomes malleable and takes the mould that you're giving it. So the fidelity is superb. That started at just under 4 litres and it's ended up with just over 2.5 litres, purely by a bit of vibration and gravity. This is the same sort of effect that you'd expect with bias on a tape. It's the addition of the two forces which gives you the results, which in this case is a nice smooth pot of powder, and in our case would be a really good sounding tape. You may have heard of high bias, normal bias and metal bias. These are all different levels specific to the type of tape being used. If you've got a type 2 tape, you cannot bias it the same as a type 1 tape. Most types are manufactured to a standard, so they are around about the same for each type. But on high-end machines you can get controls which actually are there to allow you to fine-tune it. On some machines you can get quite sophisticated. You can start setting the levels so they exactly match what you record and what you get off the tape. This allows you to custom tune the tape to the machine. These functions are nice but not necessary. It depends on what sort of machine you've got. However, if you've got the right tape for the right machine, it doesn't matter whether there are knobs on it or not. If it is set to the tape when manufactured, it will be giving you the best it can do. Most of the tapes are mostly right most of the time. It's worth trying one to see if you're happy with it. Then buy more or don't. Because the tape has to be set for the machine and the machine has to be set for the tape, the diagram in the middle on here shows you the correlation between bias level and response of the tape. If you apply more bias, then you get a better low frequency response, but you lose the treble. If you take the bias level down, you lose your bass, but the treble will be brighter. It is a case of getting it right in the right place so you get the best of both worlds. One of the things you'll hear people say, which is really confusing because it is totally wrong, is you've got to give it some negative bias, or give it some positive bias. You can't give it negative or positive bias. Bias is set to a level. You can set a lower level or you can set a higher level. It's just that the knobs are marked positive and negative, or plus or minus, to show which way to turn them. Don't get confused, don't worry about it, just set it to what it should be and you're sorted. I want to show you this in the real world. This is a tape, a brand new tape. I'm going to get it out, I'm going to put it into my deck, and I'm going to fiddle with the bias control and explain what's happening. So you can see really what's what. Brand new tape, new old stock, I would guess. Right, so brand new tape. So we have a brand new tape, or rather new old stock. We put it in the deck and set the frequency up. We use 150 Hz on one channel, which gives us bass hum, and 7 kHz on the other channel, which gives us treble, hee. Both are set to be exactly the same level, which is 0 dB. Next we're going to adjust the bias. We put it in record mode and start turning the knob bit by bit. We start at the total minimum it will go, then turn it up step by step. When you play it back you will see the results. It's quite interesting and a handy way of setting up your machine if you don't have a tone or auto set. I've got a standalone video on doing this, which you might find interested on my channel. As we adjust the bias, we notice that the bottom signal becomes bigger. As we step it up, it becomes equal, then bigger. What you have to do is set it to where it's the best, which was equal. It was on 9 on the counter. Now, we could just play a lot of music and twiddle the knob saying, listen to the difference on there. But you wouldn't actually get any benefit because, 1, I don't know what you're listening to me on, and 2, you don't know what it's meant to sound like anyway. So at the end of the day, you wouldn't hear anything that is really any better. The key is to understanding the process and adjust according to your specific setup and preferences. Finally, we've reached the last bit, recording levels. If you push the tape too hard, you'll overdrive it and start to clip. Imagine a black line on a diagram moving into the red zone and also into the noisy nonlinear section. This means you're going to get sounds that aren't quite right. When you overdrive, you won't be able to push as hard as you like. You'll take off the top and bottom of the curve, resulting in sounds that are off. You can show what they look like here, but unfortunately I can't let you hear them because we're on YouTube. Let's look at some pictures. The top right hand picture shows a waveform with a sag. Something you might get with a low battery in a cassette recorder. The top left-hand picture shows what the actual audio going onto the tape would look like. That's a bias signal with a low frequency tone on it. The bottom one shows what a clip signal would look like. It's not pleasant to look at, and it'd be even worse to listen to. Now let's look at some more pictures. The first is a pure 1 kHz tone from a digital source. The second is a playback from a recorder. This tone was recorded at a perfect 0 dB. You can see there are some spikes. There's one at 3 kHz and one at 5 kHz. This is called harmonic distortion, and it happens because the volume is being pushed up to the point where it's starting to clip. These spikes are audible and would give you a raspy shrill sound within the sound that you're listening to. I can't actually play it for you because we're on YouTube, but I can show you this, the same frequency at a lower level. There is no distortion, no peaks on it. That's how important it is to get it right, and it will sound beautiful. You might hear about other things depending on who you're talking to, but they're not really important to most people. Terms like mol and sol simply refer to the quality of the tape, but it doesn't really matter. You set it up as we described, play it back, and if it doesn't sound right, you've got a problem. But if you set it up within the normally set out parameters, which is 0 dB or less, better to be slightly less, you'll get good results. That's the way you want it to be. The other stuff is all getting a bit geeky. We want to keep it simple. That's a lot I could go into, but we won't because we want to keep it simple. I hope you've got a basic understanding of how a cassette and any other tape recorder works now, and how important or not some of the features are. Keep an eye out for other videos on special features like speed setting, etc. If you've got something out of this video, then I'm glad you enjoyed it. If you'd like to, please subscribe and hit like. YouTube will treat my videos better and put out more. Let me know if there's any videos you'd like to see in the comments, and thank you very much. Bye bye.